Hi everyone. Okay, so this is going to be the video for number 32 from the problem book. So we'll just kind of start out and work our way through the problems, or through the questions here. So it says, first write a formula for the distance from a -1, 5 to p x, y. And then there's some other stuff. So first we'll just do that. Okay, so from the distance formula, let's get this down here. We can write, we remember that it looks like this thing. x2 minus x1 all squared plus y2 minus y1 all squared, and that's all underneath the square root. You could have the x1, you could have these in either order, and the y's in either order too. So let's make this our x1, y1, and this our x2, y. And so then we're just plugging straight in. So the distance from A to P, AP, would be the square root of, we'll go x minus -1, so x plus 1, all squared, plus y minus 5, all squared. And if you had flip-flopped which one was, like if these were your 2's and these were your 1's, you could have gotten instead -1 minus x, all squared, plus 5 minus y, all squared. So that's AP. The next question says, write an equation that says P is, write another formula for the distance from P to B, 5, 2. Okay, so P to B, we'll make, let's do this. Let's make P, we'll make this one x1, y1, and this one x2, y2. So PB is going to be the square root of, let's see, x2 minus x1, and then y2 minus y1. Or if you reversed which one was x1 and x2 and y1 and y2, you would have instead gotten x minus 5 squared plus y minus 2 squared, all underneath the root. Okay, and it doesn't really matter which version you have, as long as you've got one of these red ones for AP and one of these blue ones for PB. Okay, the next part is now write an equation that says P is equidistant from A and B. So if P is equidistant from A and B, then that means PA is to equal PB. And PA is the same as AP. So I could take one of these red terms and make it equal one of these blue terms. So it doesn't really matter which one we pick, but this first one looks a little bit better than the second one to me. So I'll say root x plus 1 all squared plus y minus 5 all squared equals, and then I'll pick a blue one here, and it doesn't matter which one you pick. So I don't know, I'll pick the first one, 5 minus x squared plus 2 minus y squared. Okay, so that's an equation that says they're equidistant, because it says PA and PB are the same. Then it says simplify to linear form. Right? Linear form, you guys know some linear forms, like this one, x plus by equals c, or y equals mx plus b, or y minus y equals m, x minus x. These are all linear forms you should have learned at some point. Well, the only variables in them are x and y in each case. The a, b, and c in that first one are constant, or actual number constants. In this one, the slope and the y-intercept are constants, but the y and the x are just variables. Same deal down here. These are variables. Everything else is some sort of constant. So linear form really means You have x's, y's, constants, and that's it. So you never end up, so no x squareds, y squared, cube, square root of x's, etc. Just single x's, single y's, and constants that go with them. Okay, so it says simplify the equation for the equidistant stuff to linear form. So we'll simplify it. So one way to start is square both sides to get rid of these roots. So then I've got x plus 1 squared plus y minus 5 squared equals 5 minus x squared plus 2 minus y squared. And then in the next step, I'll actually multiply out x plus 1 times x plus 1, y minus 5 times y minus 5, and so on. And no matter which version of the red expression you picked and which version of the blue you picked, this next step here should be the same for everyone once you square all your terms out. So, well, actually, let's go 2 steps from there. We'll all do the same. So I'll first break this out. And my guess is a lot of you don't need this step. So feel free to skip something like this. You'll have to square it by in your head. And then different people have learned how to multiply out these binomial terms. Some people make like little kind of box charts where this is x plus 1, and then you kind of add up all these areas that you would get here. Some people just do the foiling technique. So it's up to you how you want to do it. Whoops, sorry about that. So, what's going on? Sorry. Okay, so we end up with, if you FOIL it, you've got x squared plus 1x plus another x, so it's 2x plus 1. And then this part turns into y squared minus a 5y minus another 5y plus 25 equals, and then over here we've got 25, and then minus 5x minus 5 more x plus x squared, and then plus 4, and then minus 2y, and then minus y times minus y is plus y squared. Which looks terrible, but there's a lot of simplification that happens here. The x squareds cancel on both sides. These 25s take care of themselves. What else happens? We've got the y squareds cancel, right? And then let's see what happens if we simplify just a little bit. If we get all the x's and y's on one side, so here are my x terms. If I bring that negative 10x over, I get 12x. Whoa. Sorry about that. All right, so we get 12x. And then if I get the y's all on one side, I'll add 4 to both sides. So this becomes minus 6y. Minus 6y. So now I've taken care of my y terms. And then I'll bring the 1 over to the other side. So that becomes 4 minus 1 is 3. And then I can simplify that a little bit. If I divide by 3, divide by 3, divide by 3, there's a pretty simple equation in this form. Right there. Okay. If you prefer slope-intercept, you can just isolate the y. Negative 2y equals 1 minus 4x. Divide by negative 2. So it becomes negative 1/2 plus 2x. And then most people like the 2x in front minus 1/2. And there's your slope-intercept form if you prefer that. Y equals b. Slope-intercept versus standard. And either one's fine. Okay. So if you think about what you just did, you ended up taking 2 points, A at negative 5, and B, which would be at 5, 2. So that's what? 1, 2, 3, 4, 5, 6. 1, 2, 3. So it'd be right here at 5. So there's B, there's A. And you said that point P, which is some xy, is equidistant from it. Well, if you looked at all the points that are equidistant, you should by now be thinking about the perpendicular bisector. Any point on a perpendicular bisector is going to be equidistant from the endpoints that it's bisecting, of the segment it's bisecting. So really, all these points right here, those are all the different possible P's that you could have that satisfy these equations right here. So it asks, so this equation right here is the equation of that blue perpendicular bisector there, right there. So then the next question is verify it, or the next part of the problem is to verify by calculating two slopes and one midpoint. Okay, so the two slopes you're going to need, we could figure out the slope of this thing right here because I have the two endpoints. And if you look at it, it's down 1, 2, 3, and over 1, 2, 3, 4, 5, 6, down 2 over 6. This guy's slope is negative 1/3, which means the slope of the perpendicular bisector must be 3 over 1. Wait, I messed something up here. Down 3 over, oh, sorry, it's down 3 over 6. So that means it's slope of negative 1/2. So this one's a slope of positive 2 over 1. Well, that's good because that's the same exact slope we get in the mx plus b form. The other thing we need is a midpoint. That's this point right here, which you could get a couple ways. You could average the x's and average the y's. You could figure down 3 over 6 turns in to get to the midpoint, instead go down 1.5 over 3. It's up to you how you want to do it, but I'll do it this way. Midpoint of AB. I prefer the averaging. I just think that's a little bit easier. Negative 1 plus 5. So average the x's, average the y's. We end up with 4 over 2 and 7 over 2. And that doesn't do a whole lot for you unless you check if it's actually on the perpendicular bisector, which you can do by testing to see if it works in the equation of the perpendicular bisector. So you can plug this either into that one or this one and see if it's true. So check if, I'll call midpoint, if M is on, or let's say, let me do it this way, satisfy the equation of the bisector. So why don't we do the well, let's do the slope intercept since we already work with that. So y equals M is this point. So I'm going to take 2 for the x and 3.5 for the y. And I'm going to question whether or not that's true. So if you think about it, 3.5 does equal 4 minus a half. That's good. So since M satisfies the equation of the perpendicular bisector, it is on the perpendicular bisector. And so that's a way of kind of verifying that it looks like we did it right. Okay. I hope that helps a little bit. And yeah, okay. If you still have questions, you can ask me next class. Thanks.